All right, today we're going to look at acceleration. Okay, so you've all heard the term acceleration before. You press the accelerator in your car. So we're really going to look at what exactly does that mean. Okay, so first off, your acceleration is looking at the rate of change of your velocity. There you see that word rate again. So you're talking about something per time. So it's literally looking at how fast you're changing your velocity. Acceleration is represented by the lowercase letter a. V is still your velocity. It's the change in your velocity. So there again you see that delta. Remember, anytime you see that delta, it's always final minus initial. And then over your time, that's that rate part that I was talking about. If you think about the unit for velocity, it is meters per second. And then your time is seconds, so your unit for acceleration is meter per second, or simply meters per second squared. Since your acceleration is based on velocity, and when you're looking at velocity, you have that directionality with it, that means that direction is also going to be important for your acceleration. So your acceleration can be positive, it can be negative, it just depends upon what that change in your velocity ends up being. Okay, there are also 3 ways that you can accelerate, so you'll want to make sure you jot these down. You can accelerate by speeding up, so literally increasing your velocity, slowing down, decreasing your velocity, or changing your direction, so changing which way you're traveling. Because if you think about it, if you're traveling east, that's a positive velocity. Then if you start traveling west, you're now going negative velocity. Even if you're traveling at a constant speed, your sign on your velocity has changed, therefore you have accelerated. So your 3 ways that you can accelerate are speeding up, slowing down, or changing directions. So that means if you're traveling on 610 at a constant speed, you are still accelerating because you're changing directions because you're on a loop. You're on a circle. So those are just 3 ways. Keep that in mind as you're looking through examples. I promise you that'll show up somewhere again. All right, so let's go through an example. This is not in your notes, it's just a practice one. So you have an aircraft goes from 0 to 60 meters per second in 13 seconds. Calculate the aircraft's acceleration. So you're going to go back and you're going to use that equation for acceleration, delta V over delta T. Your final velocity was that 60 meters per second. Your initial velocity was 0, and then your time was that 13 seconds. So A equals delta V over delta T. So 60 minus 0 over 13 gives you 4.62 meters per second. Again, if you don't like the meters per second, I don't. Just write meters per second squared. Make your life easier. Okay, as you're going through it. Then you can also have the same thing, only now it's landing, so it's going from 60 meters per second to 0 meters per second in 11 seconds. Again, you're going to calculate the acceleration. Acceleration is still delta V over delta T, only now your final velocity is 0, your initial velocity is 60. So when you look at that equation, you're going to have 0 minus 60. That's going to give you a negative answer. Okay, so you're still moving in a positive direction. Okay, if you look at your velocities, these are both positive, so you're still moving in a positive direction. Only now you're slowing down, so we say that your acceleration is negative. Okay, so you're decelerating. Decelerating is just another way to say slowing down or a negative acceleration. Okay, so if you see a problem and you're talking about you're decelerating, you're slowing down, that's telling you that your final velocity is smaller than your initial velocity, so your acceleration is going to be negative. Okay. All right. This slide right here, you want to star it, circle it, highlight it, memorize it. I promise you, you're going to see this again, a question about it on a test, on your homework, and it's just going to make your life easier as you're going through the graphs if you really know this slide. So when you're looking at positive and negative, you're talking about the directions, not increasing or decreasing in amount. So you're looking at which way is your acceleration going. Is it going in the same direction as your motion, or is it going in an opposite direction of your motion? So you're said to be speeding up if your acceleration and your velocity have the same sign. So if you're going to the right and your acceleration is also to the right, that means you're speeding up, because there's something pushing you in the right, making you go faster. If both of your signs are negative, that also means you're speeding up. So if you're heading south and you think about gravity, which pulls things down, acceleration due to gravity is going to be a negative. Okay, that's also going to be your speeding up, because your motion is down and your acceleration is pulling you down. So it's pulling you down faster, so you're going to be speeding up. If your signs are different, so your velocity and your acceleration, one's positive and one's negative, it doesn't matter which is which. If they are opposite signs, you're slowing down. So if you're moving to the right and you have a positive velocity, but your acceleration is negative, that means it's pressing back on you the opposite way. That means that those two are going to be trying to cancel each other out, so you're going to be slowing down. The same thing, you think about like the ball. So when you throw a ball up, your velocity is positive because it's going north. Gravity is still pulling on that ball down. Eventually that ball is going to come to a stop and start moving back down. Okay, so that means you're slowing down, because your acceleration and your velocity are in two different directions. Okay, so when you're writing down your givens, if you write down your givens and include those positives and negative signs, you can already tell if you're speeding up or you're slowing down just from looking at the signs. All right, so your acceleration, so again, you have that equation, delta V over delta T. You can look at it also in terms of a graph. So we mentioned briefly in the last lecture about velocity versus time graphs. So if you have a velocity versus time graph, remember velocity would go on the y, time would go on the x. Time almost always goes on the x-axis. If you do your slope, which is rise over run, your rise would be your velocity, your run would be your slope. So your slope of a velocity versus time graph is your acceleration. So on this picture here, go ahead and draw this in your notes just to sketch it. This is showing you a constant positive acceleration. If you look at your slope of your line, your slope is positive, your velocity is positive, it's above the x-axis, this means you're speeding up. And if you look, your y is getting bigger and bigger and bigger, so yes, you are in fact speeding up. Okay, so this is showing you constant acceleration. Constant acceleration means that you're increasing your speed at a constant rate. So this is not the person who, when the light turns green, they floor it. Okay, that's a curve, which I'll show you that in a little bit. This is the person that sits there, and when the light turns green, they steadily press their foot on the gas pedal, applying like the same amount of force, so that way your car is increasing its speed at the exact same amount each and every single time interval. Okay, so you're not going to get that jolt of being like thrown back in your seat, okay, when they like hit the gas pedal or anything like that. It's just going to be a nice, smooth transition. It's also not, no offense to my mother, love my mother to pieces, but my mother's a very cautious and careful driver, so it's not going to be my mom either, where she like the light turns green and like it's like a slow hesitation and then she speeds up. Okay, this is not that person, so it's like somewhere in the middle. All right, so take a minute or take a moment and sketch this graph in your notes. Okay, so you have a velocity versus time graph. Again, velocity is going to be on the y-axis. Time is going to be on the x-axis. And then we're going to go through and find the acceleration in these different time intervals. So go ahead and sketch it in your notes. A reason I want you to sketch this one is so that way you have something to refer back to when you go to work on the homework problems. So that way it can help you out a little bit. It doesn't have to be perfect, just making a sketch. Okay, so the first thing that you're looking at on this problem is what is the acceleration from 0 to 3 seconds. Okay, so again, you're looking at your slope from 0 to 3. So you're looking at this straight line right here as you go through it. So you're going to do rise over run. So your rise would be 60. Your run would be up to 3 seconds, so it ends up being 60 over 3, which would give you an acceleration of 20 meters per second squared. Okay, that is just the acceleration in that time frame. Then you're going to do what is the acceleration from 3 to 5. So now you're looking at this second part of the line. If you look at 3 to 5, it is a horizontal line. If you're looking at a horizontal line, what is the slope of a horizontal line? It is 0. So this means that you're moving at a constant speed. You're not stopped because your velocity isn't 0. So if you're thinking about this in terms of like a real world example, you started at rest, you accelerated up to 60 meters per second, and then now you're driving on cruise control for 2 seconds. Okay, then if you come down here and do this back part from 8 to 9 seconds, we can find our acceleration. Again, looking at your slope. If you look at your slope now, it's going to be negative. So my initial velocity would be 60. My final velocity would be 0. 0 minus 60 over that 8 to 9 seconds would give me negative 1, or would give me 1. So it's negative 60 meters per second squared. Okay, so that's what you need to look at when you're going through these graphs. So look at number 24 in your homework problems. Okay, so go ahead and look at 24. We'll go through this one together. So what I want you to do real quick is go through it again. This picture should look very similar. It's a similar graph to the one from the homework the previous night. So go through this and answer A through F, and then we'll go through them. Okay, so if you're looking for which ones have a constant velocity, again, you're looking at for which ones are going to have a straight horizontal line. So your constant velocities are going to be A and E. Okay, A is going to have a constant positive velocity, E is going to have a constant negative velocity. Which objects are accelerating? It would be B, C, and part of D. Okay, so D is accelerating in this beginning section. It's changing its velocity at the beginning, and then it changes to a constant. Okay, B changing its velocity the entire time, C changing its velocity the entire time. Which objects are not moving? For C, that would be none. Okay, in order to not be moving on a velocity versus time graph, you would have to be right on the horizontal axis, right on top of time. Sorry, my clock is going off again. I don't think about it, the timing. Okay, then for D, you're looking at which ones are going to change directions. If you think about it, if you're going in a positive velocity, that means you're going north or east, depending upon which way you want to look at it. A negative velocity would be south or west. So you have to look for, when you're talking about changing directions, which one literally crosses the x-axis. So that would be B, and that would be C. So B is going to change up at this early point right in here, and then C is going to change directions later on. Okay, so this would be anytime you take like the turnarounds, make a U-turn, you're changing directions, your velocity is going to go from positive to negative or negative to positive, just which way you're moving. Okay, you're driving a car, and then you realize you forgot something, so you turn around. Okay, that's going to be a change in directions. Your velocity is going to go change signs. For part E, you're looking at which one has the smallest acceleration. So you're looking for which one has the least or the least steep slope. So the smallest slope, and that would be C. And then if you're looking for which one has the greatest velocity, you're looking for which one is at the furthest point from the x-axis. So that would be E. E has the greatest overall velocity. Yes, it's negative, but it still has the greatest numerical value of velocity. A would have the greatest velocity the entire time in terms of positive. B eventually goes faster than A since it's higher. But if you look at this distance B ends up from the x-axis versus how far E is still a lot further from it. Remember, when you're talking about positives and negatives, that's a direction. That's not telling you that it's some sort of negative small number. That's telling you that you're traveling west. So E is going very fast, either west or south, depending upon your frame of reference, where are you starting from. All right, so draw these graphs in your notes. Okay, so this is showing you what it would look like if you have a positive velocity and a negative acceleration on 3 different types of graphs. So remember, you have a positive velocity and a negative acceleration, so that's telling you that you're slowing down because your signs are different. So if you look at the first one, look at what's happening to your slope. You're traveling in the positive direction the entire time because you're always moving away from the origin. Away from the origin is positive. But look at your slope. Your slope is getting flatter and flatter and flatter and flatter as you move on. The slope of a position versus time graph is your velocity. So you're moving in the positive direction, but your acceleration is negative, so you're slowing down. Here's what it would look like on a velocity versus time graph. You would be starting out moving, again, you're staying above the x-axis. Above the x-axis is a positive direction. I cannot stress that enough. Below the x-axis is a negative direction. So this entire time on this middle graph, you are moving in a positive direction. You're just making your velocity smaller and smaller and smaller. So this would be you're heading to the right, and you see a stoplight up ahead, so you start slowing down. You're still moving to the right, so your velocity is still positive, but your velocity is getting smaller. So then what that looks like over here on your acceleration versus time graph is it would be a straight horizontal line below the x-axis. Okay, again, since it's a negative acceleration, that's telling you about the direction. The force that's making you change speed is going in the opposite direction from which way you're trying to move. Okay, you're not going to see too much with acceleration versus time graphs. If you take AP Physics, you'll see acceleration versus time graphs a lot more, but for pre-AP, we don't worry about them too much. We mostly focus on position, time, and velocity versus time graphs. All right, so if you want to find your displacement, so if you have a velocity versus time graph and you want to find your displacement, the way to do that is to find your area. So if you think back to your velocity equation, your velocity is displacement over time. If I solve that for displacement, so for delta x, I would get delta x equals delta t times v. It's basically my area. Time would be the base, v would be my height, so delta x would be your area. Okay, again, if you want to look at it just in the sense of units, if you want to end up with meters, that means you need to have seconds times meters per second, and that will give you your displacement. Okay, so it's just another way to look at it from the same thing. All right, again, we'll go through this one. Okay, so here you have a velocity versus time graph. If you want to sketch this one in your notes too, be a good idea. So you have a velocity versus time graph. Again, velocity is always on the y, time is always on the x. You're starting from rest. You go up to 20 meters per second. So you have a constant positive acceleration. During section B, you're traveling at a constant speed. And then during section C, you're still traveling in the same positive direction because your velocity is still positive. You're still above the x-axis, only now your velocity is approaching the x-axis, so it's getting smaller. So you're slowing down. Okay, so if I want to figure out how far did I travel during my time interval A, I'm going to find my area. Okay, so the reason I can't use that velocity equals delta x over delta t, because I'm not covering the same amount of distance each second, because I'm speeding up. So as you're speeding up, you're increasing that velocity. That means that each second you're going to be covering a little bit more ground, so that equation doesn't work completely. Okay, so if I want to figure out how far I'm supposed to travel during section A, all I have to do is find the area. You are going to need to know the area equation of a triangle. Okay, 1/2 base times height. So 1/2 base times height would be 1/2 times my base, which would be 10 seconds during section A, and then times my height, which would be 20 meters per second. So that way your units will again cancel out, because you'll have 10 seconds times 20 meters per second. Your seconds will cancel out. And your area, or your displacement during that first time interval, would be 100 meters. Okay, then you'll do the same thing for B and C. So for B, you have a square. So it's base times height. My height is 20. My base that you're looking at is going from 10 to 30. So that would be a total of 20. So it would be 20 times 20, or 200. Then if I want to do C, I would go back. C's shape again is a triangle. So 1/2 base times height. So it would be 1/2 times 40 times 20. If you wanted to, you could also find out how far it traveled during the entire time frame. So overall, going from 0 to 70 seconds, if you wanted to figure out how far it traveled, you would add it up. 100 plus 400 plus 400 would tell you that you traveled 900 meters. The reason that you're adding all of these up is because you're staying in the positive direction. The entire time you're moving positively. You're moving to the right, or you're moving north. If one of these, so let's say for example at 30 seconds, you flipped upside down, and now this part was below the x-axis, that would tell you that you're going negative. So you would have to subtract that piece in terms of your displacement. Okay, so above the x-axis means that you're moving in a positive direction. Below the x-axis means you're moving in a negative direction. All right, so let's look at another homework problem. So go to your back to your homework and look at number 26. So 26, sorry, I'm trying to flip to it as well. So 26, you have to find the area under the curve, so you're looking for the distance that it's traveled. So find the distance in each one of those segments. So if you look at the first one, you're traveling at a constant velocity. So when you go to find your distance that you traveled, it would just be base times height. So 30 times 6, which would give you 180. 180 meters. For part B, you have a triangle, so you'd find the area again. 1/2 base times height, so 1/2 times 40 times 4 would give you 80 meters, positive, since it's still above the x-axis. And then for C wants to know how far you traveled from 2 to 5 seconds. The easiest way to do this, first off, if you don't know the area equation for a trapezoid, it's okay. Don't use it that way. Since it only wants the area from 2 to 5 seconds, what you can do is find the total area from 0 to 5, that big triangle, and then subtract out the small triangle. Or if you know your area equation for a trapezoid, it is 1/2 base times height 1 plus height 2. So you would add your two heights, which would be 20 plus 50, which would give you 70, times 3, your time interval, 2 to 5 would be 3 seconds, so your base is 3, times 1/2, which would give you 105. Or, like I said, you could also do the two triangles. So if you did the big triangle first, it'd be 1/2 base times height. So it'd be 0.5 times your height of 50 times your time, which would be 5. And then you could do this smaller triangle, which would be 1/2 times 2 times 20, which would give you 20. And then since you don't want the whole triangle, you just want this piece in the middle, you would subtract out this first piece. So you would be 125 minus 20, which would still give you 105 meters. Okay, so two different ways to solve it. All right, in summary, this slide, you want to make sure you write this down. Okay, it's an easy way to help you from going from one type of graph to the other. Okay, so if you have a position versus time graph, a distance versus time graph, if you want to find, if you take the slope of it, that's going to give you your velocity. If you try and take the area of it, it's not going to tell you anything. So the area of a position versus time graph is nothing. If you take a velocity versus time graph and you want to find the slope of it, that'll tell you your acceleration. If you find the area of it, that will tell you your displacement. Okay, here it shows you again the middle part. These are just three different representations of the same sort of information, just so you can see them, okay, in whichever fashion helps you. So again, in this middle one, you have a position on the y-axis, time on the x-axis, and it just shows you that your slope is your velocity. This last one, okay, you have a velocity versus time graph. So it's showing you that your slope, again, is your acceleration, and then your area is your displacement. And then again, here it tells you if you take the slope of a position versus time graph, it gives you the velocity versus time graph. If you have a velocity versus time graph and you take the area, it will give you your position versus time graph. Okay, so several different ways to look at them. I think this slide really helps because you're going to have to be able to go from one graph to the next graph to the next graph.